Hello, everyone, and welcome back to another episode of Solidity Fridays. Today, I'm joined by co-host Gareth Larkin, also from Linum Labs, and we'll be looking at Permit 2, the new release by Uniswap. Yeah, how you
So,
doing, Gareth?
all good. Thanks for having me back. This is cool, man.
Yeah, sure. I'm excited to have you back. It's been ages.
Yeah, but I'm really excited to cover this. I think this is going to be big for the industry.
I think it's going to become a new standard. Yeah, I'm really excited about it.
Yeah, I hope so. Based on how quickly, I suppose, developers adopt it, will
mm,
tell us how fast it'll grow. But yeah, I look forward to digging deep into the minds of the Uniswap developers.
I have a friend who refers to them as the aliens at Uniswap because they just do like alien technology.
Yeah, the
um,
three aliens.
So they released two things last week. It was Permit 2 and the Universal Router. I do think Universal Router we might cover in a second episode. Let's just focus on Permit 2 today.
Yeah, I agree. I think it's a whole nother section.
Yeah,
Permit
right.
2 comes with a whole bunch of cool things we can speak about anyway.
Awesome. So yeah, Permit 2 allows token approvals to be shared and managed across different applications, creating a more unified, cost-efficient, and safer UX. And we'll look into why it's those things later. Um, they've made it fully open source because they want it to be for the industry. They always give back to the ecosystem.
Yeah, that's really cool. They're very into making sure that it's best for the ecosystem.
Mm.
Um,
Cool. So Permit 2 is a token approval contract that can safely share and manage token approvals across different smart contracts. As more projects integrate with Permit 2, and this is the thing we're really excited about, we can standardize token approvals across all applications. Very cool.
yeah, this just really helps with everyone having to every time it's a different application you have to flip and allow, and it gets a bit tedious. Um,
Mm.
so standardizing something like this would be really, really cool and
And yeah, it'll be more efficient.
way more efficient. I mean,
Intern,
that's also one of the big things in uh, Web3 is the user experience. Like UX is so big because it just
it can make
allows
for an
mass
application.
adoption and stuff.
Yeah, we need better UX for mass adoption. That's true.
Exactly. So people always see UX as a secondary thing, but with Web3 it's so important. So this will no doubt undoubtedly improve the user experience. Um, like they say there, by reducing the transaction costs, um, and
Mm.
improving security, which is like a double win.
Yes. And I think there'll be one extra thing that's also easier that I don't know this, I'm assuming that because you have to do less allows, there's less function calls, less clicking on the UX. But that,
Exactly.
yeah.
No, for sure. I think that basically it'll just come down to now almost one click of a approval, and then or it's signing a transaction, a signature, and then you're good
And
to
you're
go.
good to go.
Yeah, so that's awesome because I know, especially while we've developed our applications, it's always for the user experience to have to, when they try and do something and then they first have to click approve, etc. It can become a bit tedious for the user and kind of push
Mm.
some people away.
Many people, I think, yeah.
Mm.
So it was originally defined in EIP 20. The canonical token approve method suffered from a couple of weaknesses. So this is the first approved method, the one we know and use. I've
Mm.
only just started using permit one because this approved method did have some weaknesses.
Definitely.
Do you want to read them out, Gareth?
Yeah, so one of the big ones was that every time there's a new application that someone wants to use, they would have to send an approval transaction every time. So, like we said, that the user experience here became confusing, and users having to send multiple transactions before actually using what they wanted to do would waste gas and time. So, um, this kind of solves that issue where we can have the mass adoption from all the applications working together, and one click instead of multiple clicks will save gas, save time, and save people from leaving the platform. Um, so that's really cool, and we'll obviously dig into how that works when we get into the code. And then for convenience sakes, the applications that the users asked to approve the maximum allowance, giving access to wallet's entire token balance for an indefinite amount of time, this was also like, although Uniswap, and there was no real hack that used this as a vulnerability, there was a security risk. So what we'll see, and what I assume, is that there will be a time limit on the permit for this permit 2, which also helps that, and also only having to allow a certain amount for a given transaction, instead of actually having to, give an application your entire token balance as a allowance, which is fairly risky.
Very.
So, yeah, I'm quite keen to see how they've implemented that.
Yeah. And then we got EIP 2612, which I think is the original permit. And that iterated on token approvals. And now you don't have to require prior approval and appending a signed permit message to their transaction. It made token approval safer with granular allowance approvals. Tokens launched before this did not support the permit function, and not all newer tokens have adopted it. So that's something we must look out for when we make tokens, is try and make them permit accepting.
Yeah, because
supporting.
Exactly, because the older tokens aren't compliant with it, which kind of also doesn't help with mass adoption when you can't implement the permit into your originally developed token. So I guess I think this is something else that they've also brought into permit 2, is that as we can see there, it iterates on token approval mechanism. So it introduces something called signature-based approvals, which is really cool because it, like we said, with the UX, it just means one click instead of multiple, as well as the transfers of the ERC20, regardless of your ERP 2612 support, which is really cool. So that's now being able to adopt no matter what. So it comes with a host of exciting features, so that they unlock a more secure token approval options and enable a more consistent user experience across integrated applications. So they have a full list of all these kind of really cool features, but here's 5 of them. I don't know if you want to go through them, Tam.
Yeah, right. So permits for any token. So we have semi-touched on this. So applications can have a single transaction flow by sending a signature along with the transaction data for any token, including those not supporting a native permit method. So this is huge. This really means now we can adopt permit in any token, no matter how old it is.
Exactly.
The next one is for security, expiring approvals. Approvals can, you don't have to, be time-bound, removing security concerns around hanging approvals on a wallet's entire token balance. Revoking approvals do not necessarily have to be a new transaction. And I love that. As a user, I feel much safer with an expiring approval.
Yeah, I'm actually surprised it's taken this long to become a thing, to be honest.
This is the part of Permit 2 I'm actually most excited about so far.
Oh, really?
Yeah. Cool. Signature-based transfers. So users can bypass setting allowances entirely by releasing tokens to a permissioned spender through one-time signature, which that's where the efficiency comes in.
Yeah, exactly. So they have a contract, if I'm not mistaken, called like signature transfer. I'm keen to look into it, but I know that that'll probably handle all of these type of transfers, which is really, really cool.
Yeah, I'm really keen to look at that. And then batch approvals and transfers. Users can set approvals on multiple tokens or execute multiple transfers with one transaction. So they were saving gas, and we're also just making it easier for the UX.
Exactly.
And batch revoking allowances. If something's proven to be unsecure, you can just batch remove allowances on any number of tokens and spenders in one transaction. That could have been helpful maybe with FTX a few weeks ago.
Yeah, I think a lot of the stuff that are being built now from huge companies such as Uniswap, etc., are relearning from things that are happening in the ecosystem. So it's really cool to see what's happening, watch the companies and the big players in the industry, and even the small players, just learn from it, create better solutions, and come out with really cool things like this.
Yeah, it's really great.
So Permit 2 is non-upgradable, and
which is great. They aren't going to rug us and change.
Exactly. And unowned, so decentralized is great. And an open source contract that has been deployed to the same address across Ethereum, Optimism, Arbitrum, Polygon, and Celo. So that's really cool as well.
Yeah, so it's multi-chain.
Exactly. So we don't have to I know it seems like a small thing, but like often with developers, if you're going to use it and now you want to change which chain you're using, you have to change the address of the permit to contract. So this is quite cool that if you're developing on any of those chains, you've got the same address. So yeah, and then as Uniswap do, they've also got a bug bounty. So if you can find any problems with the permit to contracts, that'll be really cool. It supports ERC20 tokens only, but as Uniswap do, they always leave you with a cliffhanger. They will be releasing a NFTs version in the future, in the near future, apparently. So that's really, really awesome, and I'm really keen to see that. But yeah, so there are developer docs which help with explaining how Permit 2 works and stuff. Should we dig into that, Tam?
Yeah, that sounds good.
Cool.
They always have a pretty good documentation, Uniswap.
Exactly. So there we go.
Okay, so it's a unification of two contracts. The one you've mentioned, the signature transfer and the allowance transfer. So maybe we'll look at signature transfer first, which is a contract that handles all signature-based transfers, meaning that an allowance on the token is bypassed and permissions to the spender only last for the duration of the transaction that the one-time signature is spent. That's cool.
Cool.
The allowance transfer, yeah?
No, I was just saying that's really cool that like the permit only lasts for that transaction.
It's clever.
It's just security-wise, it's just really good.
Yeah, really, really good. The allowance transfer contract handles setting allowances on tokens, giving permissions to spenders on a specified amount for a specified duration of time. Love it. Any transfers that then happen through the allowance transfer contract will only succeed if the proper permissions have been set. Yeah.
So that's like for the difference between what we're getting. Yeah, I mean, for a lot of people, it might sound like the allowance transfer contract is basically just the normal allowance we would be using. But as you mentioned before, the really cool thing is you get to specify the time that this allowance is actually applicable for. So this is like what Tam's really excited about, is that security wise, it's very, very good for the ecosystem. But yeah, so before integrating into the contracts, it looks like that you can request users tokens through Permit 2, but users must approve the Permit 2 contract through the specific token contract by calling something like USDC.approve. And then you approve the Permit 2 address, which is nice that it is multi-chain, so you don't have to call this function multiple times with different Permit 2 addresses because of different chains. So that's really cool. That's already saving on gas. And then the amount that you want to approve. And then...
So it is the same address, hey, on each chain.
Yeah, so...
That's so cool. I think they probably use create 3, which allows you to deploy at a specified address, and then you can choose the address across all chains. So I'd be interested to look at their deploy script. I think they use create 3. That's
that'll be really
guess
cool.
of mine.
Let's see if your guess is right. Yeah, so that's cool. It saves you having to call this approve multiple times. And then to get the maximal benefits from Permit 2, you should max approve. So total amount would be your max UN 256. So yeah, let's get into the signature transfer docs. Go for it, Tam.
Cool. So there's two main entry points. The first one is permit transfer from, and this you use when you want to transfer a token from an owner through signature validation. And then also permit witness transfer from, which is used when you want to transfer a token from an owner through signature validation, but you would also like to validate other data. This is so nice. Any other data you wish to be validated can be passed through the witness param.
Cool.
Yeah, so wow, they're really using some interesting cryptography stuff here, including witnesses. Each of these functions is overloaded with a batched version that allows users to transfer multiple tokens with one transaction. That's so cool. Maybe we don't need to actually look at the functions because we're going to look at the code.
Yeah, we're going to go through the code anyway. Let's see, parameters. Yeah, let's just check, like security considerations.
And that's a scenario. I think that's a good idea.
Yeah. So integrating contract must check that the tokens are released by a triggering call from the signer, or that the signer meant for their signature to be released by someone else. So let's consider a scenario that Bob signs a permit to transfer 100 USDC with the router contract as the permission spender. So basically, Bob signs, transfer 100 USDC, and there's a router contract that can spend this 100 USDC of Bob's. The router contract then never checks who the caller is, but spends any permit messages on the permit to contract. So what will happen then is Eve can steal Bob's signature, pass it through to the router with herself as the recipient, and transfer Bob's tokens to herself, because the router contract never ever checked who the spender or the caller is. So safety wise, it's kind of integral that you check that the caller is the person who signs the permit. I hope that makes sense.
Yeah, it made sense.
Open to vulnerabilities. But like something we'll get into in another episode, is that the universal router, which is something else that Uniswap brought out, will protect against this, because it checks that the message sender, so the caller, inside that router contract is the supposed spender, passing that sender as the owner in the permit call. So
Okay, that's cool.
really cool.
What one could do is, so either if you're not using universal router, you have to make this check yourself, or you could just use universal router. Or if you don't want to use universal router, what you could do is you could look at how they do this check, what require they use, or maybe they'll use a custom error with the if, and then implement that kind of vibe in your own code.
Exactly. So yeah, that's really cool, and I really love the Uniswap docs. Like, how good are they? They just really make things.
They are good, especially considering how complex some of the concepts that they touch on are.
Cool. So if we just want to quickly pop over to the allowance transfer function, contracts is the other one of their kind of two system integral contracts. Yeah, so you want to go through our main entry points, Dan?
Yeah, so there's approve, which you use when you do not want to set token permissions through signature validation. Just trying to think of when I would want to do that. Because I like the idea of the signature validation, because like you said, then you can have like more than one in a transaction, and it's just nice that it's signed. But yeah, let's see, maybe in the code when we're reading the code, it'll be more clear when this will be used. And then there's permit, which same thing, you can permit to set token permissions, but now through signature validation. And then transfer from, where you want to transfer a token and have the necessary permissions to do so. So that's the transfer from we all know and love.
Cool. Let's see if there's any security considerations with regards to this. So there is the nod schema, which is basically kind of helping us prevent replay attacks of signatures. So similar to standard incrementing nonces, however, they pack their nonces with an allowed amount and allowed duration. So
That's
the
cool.
nonces are then incremented per owner, per token, and per spender, not just like in general, which is actually really cool. I've never thought about that. So that obviously means that you could sign two different permits at the same time with the same nonce, and they won't cancel each other out because they're different tokens or different spenders or something. Because obviously, we often get the error where the nonce is already being used, and then the transaction reverts. So this way, the nonces are actually mapped to an owner, token, or spender. So that's really, really cool, actually.
Yeah, that's awesome.
But yeah, so some considerations would be the same as the signature transfer ones. You need to have safety checks on the caller and the passing, and that they're passing the correct addresses from the from argument. And all amounts on the allowed transfer contract are of type uint 160. So make sure integrating contracts safely downcast if they have to. See how permit to lib downcast safely. I assume they just use a safecast library or something that costs.
I think they made their own safecast library and assembly, probably, knowing them, but we'll check that. Should we dig into the code and start looking at these two contracts, and then if we have time, the libraries?
Yeah, cool. Do you want to go to the README first, maybe?
Yeah, I think it's always good to start with the README.
Cool. Okay, go for it.
Cool. Permit 2 introduces a low overhead next generation token approval meta transaction system to make token approvals easier, more secure, and more consistent across applications. So we've looked at these features actually.
I think we don't need to go through all those. There are like one or two other ones, but I'm sure we'll come across them
in the code. Yeah, I'm sure. Yeah. Okay, cool. The architecture, obviously it's those two contracts. We've seen that. Integrating, they take us to the documentation we just looked at, and Gareth's already mentioned the bug bounty. And I love that they use Foundry and not Hard Hat. So yeah, you install Foundry, and then is this lint Forge FMT, is the Foundry linter out? I missed that. I've still been using the old linter. FMT.
I have no idea.
That's cool if it's out.
It must be if they're using it.
Yeah. Yeah. Wow. The main guy who made Foundry, I'm going to say his name, Georgios Konstapoulos, says public service announcement, all Foundry users, you don't need to use Prettier anymore, or have package.json, Forge FMT is available.
Cool.
Rad. I'm going to read into that. That's a fun thing to know.
Yeah.
And yeah, and then what's also cool is you can do like, they'll probably have a nice fuzz testing because they used Forge, and the test will be fast. And yeah, you get those nice gas snapshots. And then to deploy, it's just the usual deploy that Foundry does. If we have time, I would actually love to look at the script deploy permit too.
Yeah.
I almost want to start there because I'm so excited to look at it, but let's end there.
Are you sure? Should we just see if they use create 3? Like
yeah, let's see if they use create 3.
And then we have to go. Whoa.
Oh no.
That's not right. It's written in
Look at their lib, please, underneath audits. Okay, well, they do use Soulmate, which they created create 3. So I have a feeling that they might have used it, but let's see. Okay, should we dig into, do you want to do allowances or signature first?
Boom. Signature transfer.
Cool, so obviously they first import the interface. And there's a permit errors file with signature expired and invalid nonce. So those are the two security things that we've implemented. Yep. They use an ERC20 from Soulmate, and safe transfer, always good. Signature verification, that's great. And then permit hash. I'm not too sure what the permit hash would be doing, but we'll see in the code, I'm sure.
Yeah, I think it'll probably have something to do with the time, like checking that the transaction has gone through in time. Otherwise, your time constraint, like checking that the permit actually happened in the actual transaction and not, like, I could see there being a hash involved there. So I guess we'll have to wait and see.
Otherwise, it could be like maybe they hash the details so that it's a smaller.
Yeah.
We'll see. Let's look at that library later, maybe. And then yeah, they import EIP 712.
Cool.
And they inherit it in the contract definition. So they use signature verification for bytes, safe transfer library for ERC20. Yeah, that's great. Oh, there we go. Yeah, you're right. Permit hash for both permit transfer from and the batch version. So it's to make sure that either they hash the data, because they said you can include arbitrary data, or maybe it's to hash so that that you can check if it's done in time.
Yeah.
Cool. Then they have a nonce bitmap, which is a nested mapping of address to a mapping of uint256 to uint256. And is that address the token, or is it the user calling? I think it's the user calling.
Yeah, and then it'll be a token ID probably. No, surely you would have it because they were saying it could be the caller, the token, and sorry, what is the other thing that they mentioned? The nonces. Or was it in the developer docs?
Yeah, I was in developer docs.
Spender, token, and owner. No, so I'm not actually sure what those.
What the bitmap
Yeah, what they actually
nonce bitmap is.
into.
Yeah. Okay, that we'll have to see where it gets used.
Yeah, then they've got the permit transfer from, which is one of the entry points into the contract. So you send in a struct, a permit transfer from struct, which I assume will hold like this amount, the spender, the sender, and the actual time frame for that permit. But should we go look at that struct now?
Yeah, let's actually look at that struct.
Easier. So it'll be an R signature, I assume. Struct permit transfer from. There we go.
Wow, so it also has token permissions.
Okay, so they have the nonce and the deadline. Okay, as assumed.
And then, okay, token permissions is just above. So we have the address of the token and the amount you're wanting to spend.
Awesome. Okay, so yeah, but they don't hold. So the struct itself doesn't hold from who and to who. It just holds the token, the amount, the deadline, basically.
And maybe the function checks the from who and to who. Well, to who will be to permit to. Well, let's see. And then from permit to, we say who. There's like a permit to in between.
Permit to. Where are you looking?
No, I'm not looking anywhere. I'm just thinking about like a flow diagram in my mind. But
it's cool. Then it takes in a struct of signature transfer details. That's probably going to hold. That. So if we go to transfer, address to and the requested amount. I wonder why they need to have. Okay, so the token permissions is the max amount. It's basically like an allowance, and then in the signature transfer, the transfer details, they hold the requested amount,
which might be less, yeah.
Which could be less, exactly, yeah.
And if it's more, they probably don't send it.
Exactly. So that's cool. And then they take in an owner and then the signature. So then they call the internal method, sending in the permit, the struct of the transfer details, the owner, permit.hash. So
that'll be that hashing. Should we look at that library? It might be in assembly, but maybe worth checking out.
Permit hash. Yeah, let me try and find it.
So it'll be under SRC, lib inside SRC. Libraries.
Yeah, it'll be there. There we go.
Permit hash.
So they use the hash. So they're using this.
There's two hash functions.
The one takes in a single permit, the other one takes in a batch permit.
I see. So that's for the one we're going to look at next. Okay, so the single permit hash is it calls another internal function called hash permit details. Can we look at that?
Yeah. So it's taking in a struct of a permit, a single permit, and then there's lots of hash functions, dude. I think we're calling one of these at the moment because we're sending in transfer from. So this is the hash we're calling at the moment.
Yeah, on line 59, I think you're right.
So token permissions hash underscore hash token permissions, and we send in permitted. So if we remember, sorry, going back to the permitted was the struct that we're looking at. So we're hashing the token and the max amount in this library because we're taking in permit.permitted, which is the token and the max amount.
Yes. And that's cool because now hashing that makes it more efficient to transfer the data and like embed, and then you can unhash it on the other side. So it probably makes this really fast.
Exactly. So yeah, hash token permissions, it just returns the token permissions type hash. So it hashes, basically creates a hash of this.
So we can think of token permissions type hash because it's a constant hash as almost like the salt.
Exactly.
And then the permitted is the input that we're
Exactly.
adding, and then we're hashing those two combined, ABI encoded.
So we're getting that hash here, and we're sending it in to the internal permit transfer from method, which is here. So that's the data hash. Okay, cool. So that's so that's the basically the data about the permit. Sweet. Data hash is the ERP712 hash of permit data to include when checking signature. Awesome. So you want to try to go through this one?
Yeah, cool. So we've looked at the arguments, and it's private, which is quite interesting. So does this on line 71? Yeah, that external function calls this private function. I see. So we haven't actually looked at it.
Wow, this the same function I was looking at now? Because there's another one, yeah.
That's different. This might not have that hash. It might be just of the permit.
No, it's got the hash.
Signature, transfer permit. It's all the same.
Why do they have?
It might have a different parameter. It might be like not. Maybe it doesn't have that arbitrary data. So there was the
transfer details owner's signature. Permit transfer details.
This one has an extra thing of data hash. I see.
Oh no, wait,
one extra argument. Yeah.
That's the internal method. This one.
Oh, sorry.
Has the same. I think they're exactly the same.
Is on line 73 in the top one? Sorry. So in line 73, there's an array for the signature details.
So
and then in the other one, it's not an array. It's just the signature detail single.
Batch transfers, batch permits.
Oh, yes.
Okay.
That's where the batch comes in. Okay.
Cool. Okay, cool. So at the moment, we're just dealing with a single permit. Sweet. Okay, cool. So now you are here in your private function.
Cool. So the requested amount is, remember we saw that requested amount in transfer details in the struct. So we know what that is already. Then they use custom errors here instead of requires to save on gas. And what they do is they say first, if the block.timestamp, so if current time is greater than the deadline of what we've permitted for, then revert to signature expired, and then with the permit deadline as the message. Also, if the requested amount, this is what we said they would do. If the requested amount is greater than the permitted amount, well, then it's an invalid amount and you revert.
Yeah.
Then they call another internal function called use unordered nonce with the owner and the permit nonce. Can we check that function?
Yeah. Yeah, use unordered nonce.
Okay, so this checks whether a nonce is taken and sets the bits at the bit permission in the bitmap at the word permission. Okay, so it does like a swap. You've taken the address to use at the nonce at, the from address, and then the nonce to use, the nonce to spend. Okay, so this is the nonce we're going to set, basically. So what we do is we take, okay, so it calls another function just above it. So they take, so you've put in a UN256 of a nonce, and they take that nonce and they put it in as a parameter in the function bitmap positions, which just above on line 142 is that. So bitmap positions takes a nonce, it's private pure, and it returns the word position and the bit position in that bitmap. So it just literally does some bit shift.
As a calculation.
Yeah,
There's no reading or writing of any state variable.
that's why it's pure.
Yeah.
So the word position is a UN248. You don't see those often. Of the nonce, casted 8 bits to the right.
Yeah.
And then a bit position is just a cast of the, shifted 8 bits, not casted. And then on line 144, the bit position is a uint8 casted of the nonce, which was a uint256. And now we've just casted it to the uint8, which means we'll lose some on the right, some like almost decimals of the nonce. But that's fine because the bit position is just where it is in bits.
Exactly.
Because there's 8 bits obviously in a byte, and we have 256 in the uint256. So it's almost like dividing by 8.
Yeah.
Well, like setting it into 8 units of 8.
Exactly.
That casting. So we cast it, and it returns both the word position and the bit position. And now we say the uint256 bit is bit position shifted by 1, and then flipped is literally you just flip the bits.
Mm.
And then if flipped, so
they're just checking that they don't both equal 0.
Yeah, and if they do, then it's an invalid nonce.
Yeah, then it'll throw an error. So this basically is just checking that the nonce is valid and that no error gets thrown.
Okay, cool. We can go back to that private function then.
Cool. Yeah, so we're basically just checking that the nonce is valid. Cool. Now you can carry on.
Then we verify the signature, putting in the owner and the data hash. But we first call, so we're calling 2 functions in this line. The first thing we're doing is we're calling verify, but the parameter that we pass in first is also a function call on data hash. So we hash type data, and I'm sure all that is just going to call a catch-jack on the data that we pass in. But we could check it out in the hash library, but I don't think we need to.
No, that's just going to do, yeah.
And then it verifies the signature.
That data hash, that hash function we called.
I do love signature verification and seeing how different people do it. So maybe we could look at the verify function. I do think it might be in, I don't think it'll be in this file. It'll be in, let me look around. Maybe in library signature verification. Is there a library? Yeah, there's a library signature verification, and we can look at the verify.
There we go.
Cool. It is not very commented. Cool. So we have R, S, and V. Just trying to remember what those values are. S is our statement, R is our randomness, and V is our verification, I think.
This is not my speciality, I'll be very honest. It's signatures.
Yeah, I love learning about it, but yeah, I think R is our randomness. And then S will be a bytes representation of the signature, but we'll see this below. And then V might be the validation. So it takes in 3 parameters. Call data signature hash and claimed signature. What I find quite interesting is when we called verify, we actually only passed in 2 parameters, the hash of the data hash and the address of the claim signer, which means that this data hash type data must return 2 things. It must return the signature and the hash. Does that make sense? So if we were to look at hash type data, I think it returns the first 2 parameters.
Oh, yes, you're right. Sorry.
And then the owner is the third, which is quite interesting.
Yes, so hash type data obviously returns the signature.
And the hash.
Okay, cool, yeah. And then that's the owner.
That's
the
cool.
claim signer. Okay, cool. Yes.
Cool. If claim signer.co.length equals 0, Okay.
Why would we check?
I think we're checking it's not a contract.
Maybe.
It's an externally owned address, not a
Yeah.
contract. And if the signature length equals 65, then we ABI decode the signature. So the signature is a hash,
Mhm.
and we pass in.
And that will return R and S, the randomness in the
Yeah,
statement.
yeah, basically. And then what's next? Otherwise, if it's 64, interesting. Then it's a different type of signature. That's EIP 2098.
VS.
So EIP 2098 is the compact signature representation. So it composes the client. So that's why the length now is 64 as opposed to 65. So
Okay.
in most cases, it'll be 65,
Mm.
the length. And in this case, for this compact signature, which is so-called they include, is a length of 64. Now they define something called VS, and then they decode R and VS, and then yeah, they combine that with the bit mask, and then they shift it 255 bits.
Hectic.
Yeah, and then okay, cool. I'm just looking at this. So then, yeah, I must look more into signature verification actually.
Yeah, but it seems like they're doing it like kind of all inclusive, making sure everything's included. Really cool. But I'm keen to jump back into
Yeah, cool, because we're
um
going up on time. Maybe I'll do a signatures episode, and then we could look at this as one of the signature verifications, and we can look at multiple signature verifications. So they verify it's a valid signature, and then they do ERC20 permitted.token. So that's the address.
yeah, that's
What
the
they're saying is they make an ERC of, let's say, USDC,
yeah.
and then they call the safe transfer from function of that ERC20. Oh, sorry, because token's actually an address. So they
Token
make an
address.
ERC20 at an address.
Yes,
And then
they
that
basically
ERC20
they're getting
can be
that
any
ERC.
token. Yeah. Safe transfer from owner, transfer details.to of the requested amount, not of the approved amount, the requested amount. So that's cool.
Yes.
So you could approve for a few things.
Exactly.
Okay, cool.
So that's cool. Cool. Then they've got this permit transfer from, which is what seems like just, oh, well, I mean, it literally says permit batch transfer from. So that'll be a struct again in the signature transfer, permit batch transfer from. Yeah. So you'll just have a array of permitted structs. As we know, permitted of token permission structs, which is the token and the amount that is going to be maximum allowed. So they hold that. Then they have an array of signature transfer details, which will be in the interface as well. They're taking the owner and then the signature once again, and very much like the previous method, they just send it all into a to this internal permit transfer from function, which we've just gone through.
Yeah.
So yeah, that's really cool.
It's clever with this, sorry, this permit transfer from on line 71. It's so clever to make it on line 73 an array, because that way you can either do a single permit with the one element array,
Or multiple.
or you can do a batch.
Yeah.
It's really elegant.
Yeah, because exactly. It's actually really, really smooth. That's actually really good. Cool. So permit witness transfer from, which is the other entry point into the sorry. Yeah, okay, sorry. So let's go through this permit transfer from for the signature transfer details for batch transferring before I jump around.
Yeah.
But so the number permitted is basically your permitted struct. I think it was permit.permitted. Permitted. Yeah, so this dot length. What does that do, by the way? What is
Because we could have multiple tokens, I think. So we could have multiple addresses and multiple amounts.
okay? So
I
I guess
think.
length of that. So then it just checks that once again we're not past our deadline, and we check that the number permitted does not equal the transfer details dot length. So transfer details. Oh, we want to make sure it does equal. Sorry. Yes. Okay, that makes sense. So we want to make sure that the amount of transfers that we've sent in is also equal to the amount of permits we've sent in. Can't have 3 transfers but only 2 permits. So you need to make sure that the amount that you've permitted is equal to how many transfers you're going to deal with. So that makes sense. Cool. Once again, just verifying the nonce, verifying this.
I actually think R in that verification was the calculated output. But anyway, we verify. And then obviously this next thing, they can't underflow or overflow, and they've checked that. So now they do it in unchecked to save gas.
Exactly. So that will actually save quite a bit of gas, especially in a for loop. But it's interesting because I've read like quite a lot about rather doing do while loops instead of for loops, as they actually save a little bit of gas.
Oh, cool.
So that's interesting. But yeah, basically, so the number of permissions they've had or permits that are coming through, they're looping that many times. And what they're doing is they are getting that permitted struct, which holds the amount and the who it's going to go to. They're getting the requested amount by calling the transfer details at the current position we are. So they're kind of linking the permit to the transfer details, so that permit A and transfer details A kind of match with each other. So they're doing the check that obviously the requested amount is not more than the maximum amount that's been allowed. And then if the request amount doesn't equal naught, so in other words, it's between naught and the max amount, and then we create a token with, or an ERC20, not create, sorry, we get the ERC20 token at that address, and we call save transfer from. So we just loop through this. It's basically the same as the previous transfer permit transfer from, but now we're just looping through it to make sure we can do it.
To do multiple. Right. That's so cool.
So yeah, that's very cool. And
Should
then
we look at allowance, or is the permit witness transfer from, right?
Yeah, I noticed that this permit witness transfer from also calls the permit transfer from method, but it sends in, instead of hash, it hashes with witness.
Oh, cool.
So the only difference is, I don't think we need to go into that right now, but the only difference is instead of just hash, you hash with witness, and then you literally call the same function. Cool.
Right.
Let's jump into allowance. Let me zoom in a bit. Cool. I don't think this will be too hectic, but we can jump into it quick. Basically just imports the ERC20, safe transfer, all our imports that we did in the previous one. And then in the contract, we inherit the ERP 712 and the interface for allowance transfer. So basically the structs that we're going to need. Signature verification for bytes, all the standard stuff, and allowance, using allowance for packed allowance. I'm not sure what that is yet, but I'm sure we'll look into it. They have like a quadruple mapping, kind of triple mapping, where they map an address to an address to an address to a packed allowance. So that's the owner address first, then it's going to be the token address, and then the spender's address. So the owner could technically have multiple tokens that he's allowing for, and in each multiple token, he could have multiple spenders that he's allowing for. And then packed allowance is obviously a struct, I would assume, in yeah, there we go. So the allowance is just the amount, the expiration, and the nonce. So that's really cool. So they're mapping from an owner to a token to a spender, and then the details of that allowance.
It is like details, yeah.
Cool. So then they have the approve method that we know, but with its extra kind of credentials with the expiration. So what they do is on approve, they create a new packed allowance, and they update amount and expiration. Okay, so that's just basically adding allowed.update. Where do you think that would be update that? I don't think it's going to be in here. It's going to be...
That's the update. Oh, yeah, it might be in the library.
Yeah, but that'll just basically take that packed allowance struct and create it. It just, I'm pretty sure it'll just set the value of amount and expiration in the storage allowed value. Cool. Then it emits an event. Permit. Wonder why there's two permit methods. Oh, one's single, one's batch. Cool. You want to clap these ones?
Yeah, cool. So the single one takes in an address owner, permit single, memory, permit single. So that's that struct that we looked at. And the call data signature, which is bytes. Okay, so then they check now if the signature deadline has expired, and if it has, they revert. But if not, then they continue. They verify the signature with the hash type data, where they hash the permit single struct, the entire struct.
Yeah.
And then they pass in the owner. And then they call that update approval, which is that internal function with the permit single dot details and owner and permit single dot spender.
Okay, so basically just creates an approval or permit. Update approval is here. So yeah, it takes in the details, the owner and the spender, and then that's what I thought. It creates an allowance struct, and then basically just fills it with its data and then updates it. This allowed dot update all. Yeah, it must be a library that they...
I think it's in the allowance update library.
Yeah, okay, cool. Sweet. So where were you? Now you've got batch permits.
Cool. So it takes in a different struct as the second argument, which is the permit batch as opposed to permit single, but everything else is the same. And then it just does the same where it goes for and it goes through the permits and it updates each approval for them.
Yeah.
So that's pretty simple.
And then it's got the standard transfer from methods, but it's got the batch transferring from as well, which is just the same, but it does it in a loop. They call the internal transfer method, which will look at the allowance struct and it'll look at your expiration date so that that the expiration hasn't passed. And then it does a couple of checks that your max amount isn't more than, or is not the max uint 160, and that your amount isn't more than max amount, because if it is, they'll return a custom error. Otherwise, they will deduct the amount that's being transferred off the your allowed amount. And then they do the transfer, safe transfer from, which we know. Cool, we've got like 1 minute left. Lockdown is just so they're obviously doing unchecked because they're obviously not worried about overflow or underflow. What does this do? It makes the amount equal naught. It kind of locks a allowance. It seems to set the
Yeah.
allowance to naught.
because we don't want to. We've done it. This is how you probably revert.
Yeah, I think that's exactly what it is. It's like a safe check method.
Mm.
Cool. And then we can invalidate nonces, and we're not
That's
going to
cool.
go
So that's another way to just revert, basically, or invalidate.
literally revert the
You can change your
nonce
mind, which is nice.
and then update approval, which we've been through already.
Yeah, awesome. Thanks, Gareth.
Cool.
This was a really interesting episode,
Yeah, that was
and
cool.
a really, really cool new tool by Uniswap for the ecosystem. Really exciting stuff.
Yeah, I'm really keen to see how it gets adopted.
Yeah, we should try use it in a project or something. Yeah, awesome. I hope everyone has a good Friday, and thank you for watching another episode of Solidity Fridays, brought to you by Linum Labs.
Thanks for having me, guys. Sweet.